Hello everybody, and welcome to exercise 3 at the top of page 59 in the workbook here. This is another example involving integration. Let's take a look at what they're asking us to do here. So the table below, actually I guess it's the table next to us, not below us, gives heights of a mound where x and y are measured in meters away from the peak of the mound. Okay, and they want us to find an overestimate and an underestimate of the volume of the mound. Okay, so let's first notice kind of where the x values and the y values are in our table. So the y's are over here to the left and the x's are over here to the right. And then they're telling us that the numbers in the table are actually heights. Okay, and I'd like to draw a picture of this as well. That makes it a little bit easier to just kind of have an idea in our mind of what's going on here. Okay, so here's x and y. Okay, and we're going between -1 and 1 on both axes. Okay, and so I'm going to just kind of trace out the square that we're concerned with here. All right, and just so you can see those numbers a little bit better, how about if we put those in red? 1, 1, -1, -1. Okay. Right, what I'd like to do is to take the heights that we've got in the table above and just draw them into the diagram here. Okay, so for example, where in our picture is y equal to -1? Well, that's actually down here at the bottom, and so the heights 2, 3, and 2 would be there, there, and there. Okay, then we'd come to y equals 0, and our heights would be 3, 4, and 3. Okay, and then finally 2, 3, and 2. 2, 3, 2. So the green numbers are representing the heights of this mound at various positions. Okay, well, how do we estimate the volume of this mound? Okay, well, I claim that we can do that by calculating an integral. Let's convince ourselves of that. Okay, we can always do that by looking at units. Okay, so what are heights being measured in? Well, they tell us in the problem that heights are being measured in meters, and area is going to be measured in meters squared since x and y are both measured in meters. Okay, what units do we get if we take meters times meters cubed? Well, when we take meters times meters squared, we get meters cubed, which is the correct unit of volume. Okay, so tells us that we're on the right track here. All right, now specifically, they want an overestimate and an underestimate of the volume. Okay, so how about if we start with an overestimate? Okay, and the idea there is to take our region and maybe divide it into subsquares. In our particular case, it's kind of natural to divide this into 4 pieces. We can kind of see that in our picture here. All right, so if we start, okay, with this little subsquare, okay, we know that the side lengths of all of our squares are going to be 1. So the area of each of the squares are going to be 1. So I'm going to ignore that and put the 1 at the end. Okay, so this overestimate that we're about to take is going to be a bunch of values of our function times the area of the square, delta x times delta y, which is going to be 1 in both cases. All right, so as you look at this first square, we want an overestimate, so where is the maximum height? Well, it's right here in the center, 4. Okay, so we'll take that as our function value. And then if we move on to the square to the right of it, where's the maximum height there? Okay, 3, 2, 3, or 4. 4 is still the maximum. Okay, so we're going to use 4 again. That's the biggest height in the second square. And kind of something interesting happens here. If you keep doing this, notice that every one of our squares touches that point, 4. And 4 is the biggest number that we get, so 4 winds up being our maximum height in all 4 of the squares that we write down. Kind of strange, but that's the way it works out. So we're going to get 4 plus 4 plus 4 plus 4, that's 16, times delta x delta y, that's just the length and the width of each little subsquare. So we're going to get 1 for both of those. And so what we wind up with is just 16 cubic meters. Okay, there's our overestimate of our volume. Okay, and for the underestimate, exact same idea. We're going to take a bunch of function values, which are heights, multiply by areas. Now it's about looking at those 4 squares and asking where are the minimum heights in each square. Okay, so if we start in the upper left-hand corner, out of the heights that you see, what's the minimum height? This time the minimum value is in the upper left-hand corner, it's 2. Okay, then we move on to the square to the right. Minimum height is in the upper right-hand corner, and it's 2. And you kind of notice the same sort of thing that we notice for the maximum. We keep getting the same value over and over again. The minimum value is 2 for every one of those squares. Okay, so what that means is this time we add up our heights. 2 plus 2 plus 2 plus 2 is 8 times 1, and we're going to wind up with 8 meters cubed. There's our underestimate of the volume of this mound. Okay, so we've answered the question, and what we can say, maybe in summary, is that we know that the volume of this mound is somewhere between 8 and 16 cubic meters.